if you need to store large amounts of data, needing large amounts of data processing, and you have requirements for large analytics capabilities, you might be thinking you'll need some large compute, but that's not necessarily the case with Apache Hadoop. It's an open source framework that distributes processing of large data sets using simple programming models. Hadoop is a cost-effective solution for storing and processing massive amounts of structured, semi-structured, and unstructured data with no format requirements. And it has a pretty cool origin story. Hadoop gets its name from a stuffed toy elephant that belonged to Hadoop co-founder Doug Cutting's son. Now, before we get into the details of how it works, let's first discuss why you might need to use it at all by looking at some use cases. Now, the first benefit that comes to my mind is the ability to make better data-driven decisions, the 3Ds. Hadoop enables the integration of real-time data that traditional data warehouses or relational databases might not handle efficiently. Now, that includes things like streaming audio, video, social media sentiment, clickstream data, and other semi-structured and unstructured data. Now, another significant benefit of Hadoop is the improved data access and analysis. Now, Hadoop provides real-time self-service access to data for data scientists, line of business owners, and developers, which has utility for data science initiatives that leverage data, algorithms, machine learning, and AI for advanced analysis. It also allows the discovery of patterns and the building of predictive models, so it's very useful there as well. Now, Hadoop also excels in data offload and consolidation. So it can streamline costs in your enterprise data centers by moving what's called cold data, that's data that's not currently in use, to a Hadoop-based distribution for storage. Additionally, Hadoop allows for the consolidation of data across an organization, ensuring the data is readily available for analysis when it's needed. So with that in mind, let's take a closer look at the Hadoop ecosystem and really get into what's involved with this thing now. Now, Hadoop is designed to run on clusters of commodity computers, which makes it a cost-effective solution for large-scale data processing. And additionally, it can be installed on cloud servers. So think about cloud providers like Amazon Web Services or Microsoft Azure. They offer Hadoop solutions, and Cloudera supports Hadoop workloads both on-premises and in the cloud. Now, the Hadoop framework, built by the Apache Software Foundation, includes a number of components. Let's break down some of them. So the first one is called Hadoop Common. And Hadoop Common, well, that's basically the common utilities and the libraries that support other Hadoop modules. Then there is the Hadoop HDFS. That stands for Hadoop Distributed File System. That's a file system for storing application data on commodity hardware, so essentially providing distributed storage, which is so important to this solution. Now, HDFS was designed to provide fault tolerance for Hadoop, and it provides high aggregate data bandwidth and high throughput access to data. By default, data blocks are replicated across multiple nodes at load or write time, and it also supports high availability. That allows a secondary node to take over when an active node goes down. All right, a couple more components. There's Hadoop Yarn. That's also an acronym. Yarn stands for Yet Another Resource Negotiator. It's a framework for job scheduling and cluster resource management. It supports workloads such as interactive SQL, advanced modeling, and real-time streaming. Then we have Hadoop MapReduce. And this component, MapReduce, is a Yarn-based system, actually, and that stores data on multiple sources for parallel processing of large amounts of data. And then finally, there is Hadoop Ozone. That's a scalable, redundant, and distributed object store, and that's really designed for big data applications. Now, beyond these core components, the Hadoop ecosystem includes several supporting Apache open source projects that enhance its functionality. Now, there's really a whole bunch that we could talk about. I'll just talk about a few, and we'll start with Apache Ambari. Now, Apache Ambari is a web-based tool for setting up, managing, and monitoring Hadoop clusters, which is handy for cluster management. Another project we should really talk about is Hive, Apache Hive. That provides an SQL-like interface for querying and analyzing large data sets. Another one is Apache HBase, and that is a scalable, non-relational database that supports structured data storage for very large tables. And then just one more that we'll talk about for now, that's Pig, Apache Pig, that allows for writing high-level scripts for data analysis, enabling parallel processing. Now, a couple of other things to mention about Hadoop. It was written in Java, but depending on the big data project, developers can program in their choice of language, so Python or R, for example. And additionally, we could do a whole video comparing Hadoop with another project called Spark. They are very much related. Apache Spark is an open source framework for big data processing as well. But to summarize, we could say that Hadoop is best for batch processing of huge volumes of data, while Spark, that supports both batch and real-time data processing, and that's ideal for streaming data and graph computations. Both Hadoop and Spark have machine learning libraries, but due to something called in-memory processing, Spark's machine learning is much faster. So to sum this all up, Apache Hadoop excels in environments where large data sets and large-scale processing are the norm. Its comprehensive framework and supporting projects make it a good fit for managing and analyzing large amounts of data effectively, which is not bad for something that began life as a stuffed yellow elephant.